Okay, good morning. Here we go. Really, for whatever reason, we have a tremendous problem year after year, regardless of the skill level with this section. And people just freak out once they see trigonometry, thinking it's this really difficult concept. Now, can it be confusing? Absolutely. Okay? Are there things you do have to work through and remember? Absolutely, once again. Okay? Just like the Pythagorean theorem. Okay? Just like special right triangles. There are things that you have the responsibility to remember. Okay? One of which is how they set up. Okay? Sine, cosine, and tangent. Okay? Many of you have heard the term SOHCAHTOA. Okay? It's in part of your notes. So, this is an introduction to trigonometry. Okay? The resources, and you're going to want to go over these, trust me. Okay? The notes for Chapter 8, Section 4, the PowerPoint one. Okay? Definitely look through that. And also the notes I've provided, pages 8 to 16. And those are going to work through today's lecture and our next lecture. Okay? Just so you know. Okay. So here we go. The first thing, intro to trigonometry. We are going to deal with three. Okay? Three of the ratios. There are 6. The other 3 you will deal with later on. Okay? Trig, calculus, for those of you going that far. It is just the inverse of what we're doing here. So it's really not something new to learn. It's just, okay, I've got to think about this for a second. We're looking at it differently. That's all. So what we've got first. This is a right triangle. So triangle RST has to be a right triangle. That's how we're going to start with this. Okay? Next, X degrees and Y degrees. We have to remember that those are complementary in a right triangle. Okay? Remember, complementary angles add up to 90. We already have a 90-degree angle. 180 minus 90 leaves me with 90. Very important. You'll see in a second. Okay? Sides, A, B, and C. We're going to stay with A, B, and C just like we use on the Pythagorean theorem. Okay? And A and B are still the legs. C is the hypotenuse. Okay? Now, we also have to understand the concept of terminology, English language. How this messes with people, I really can't figure out. Okay? We have to know the difference between opposite and adjacent. Opposite is across from. Adjacent is next to. Okay? So if I look at angle T, which is Y degrees, the leg that is adjacent is B. The leg that is opposite is A. The hypotenuse is C. The hypotenuse is never, did I say that enough? Never opposite or adjacent. It is the hypotenuse. It's got its job. It does it well. Everyone's got to know their role. Okay? Okay. If I look at it from angle R, which is X degrees, the leg that is opposite is B. The leg that is adjacent is A. Yeah, there's a little bit of overlap there. So what this does, given 2 pieces of information, if you get a right triangle with 2 sides, we know, okay, we can use the Pythagorean theorem. Okay? If we get an angle, and it's not 45 or 30, 60, and a side, we can use trigonometry to find other sides. We already know how to find the other angle, subtract from 90. Okay? So this is how we do it. And it goes back to similar triangles. Okay? Remember the ratio I showed you the last lecture on special right triangles. 45, 45, 90. The legs are equal. The hypotenuse is multiplied by radical 2. It doesn't matter how large that triangle is. Okay, it can be 1, 1, radical 2. It can be 5,000, 5,000, and 5,000 radical 2. The sides are in proportion. They're similar triangles. That's what trigonometry comes down to. Okay? If I have a 5-degree angle here we know this has to be 85. You're always going to have the same ratio for a 5, 85, 90 triangle. Okay? And how do we know these things? Okay? Because we've got a chart. Okay? We also have it in our calculators. We'll get to that in a second. The three ratios we are going to deal with are the sine, the cosine, and the tangent. Yes, I used orange because it looks like tangerine and makes it easier to remember. I know. Okay? So, the ratio of the opposite leg divided by the hypotenuse. Okay? The cosine is the length of the adjacent leg divided by the hypotenuse. The tangent is only the legs, the opposite leg divided by the adjacent leg. Okay? We are going to set up fractions, ratios, and we're going to use those. We can turn those into decimals, which I will show you in a second once again. Okay? So that's what we look at. Now, using the chart or your calculator, and I do have to bring you over here and try to get you close. Each of you has this chart in, I don't know where that went. Oh, that's where that went. The timeout function is really stupid on this. Okay, so here's what I want you to understand. You've got this chart, because all I did was open Canvas, okay, go to chapter 8, and you scroll down till you see the form, or the trigonometry chart. That's all this is, okay? The sine, then there's the cosine column, the tangent column. This is the degree measure of the angle, okay? And so that goes 1 to 45 on this side, then the other half of it, we don't stretch the chart up because we don't have space, goes from 46 down to 90, okay? We're not going to deal with 90. Watch this, okay? We talked about a 45, 45, 90. If you look at this, okay, the sine of 45 and the cosine of 45, you're dealing with the same numbers, a number divided by something radical 2. Always going to be 7071, both of them. Remember the tangent, opposite over adjacent leg. Anything over itself simplifies to 1, okay? If we look at a 30, 60, 90 triangle, across from 30 degrees, you have a side. We'll call it 5 for today. Okay? The hypotenuse is 2 times 5. Okay? It's 10. So if I think about that opposite leg, 5, over the hypotenuse, 10. Simplifies to 1/2, which is 0.5. Watch this. 30 degrees, sine, 0.5. Every 30, 60, 90 triangle ever drawn since the beginning of time, okay, when Pythagoras was etching it into dirt, the sine is 5 over, is 1/2, which is 0.5. Okay? Guaranteed. Okay, so that's kind of how this works. Now here's what I want you to see. It's kind of a cool thing, because I made a point about complementary angles. Okay? Now, the complementary angles, because you're using the same 3 sides. So, if I have a 21 degree angle, okay, and I look at its sine, opposite leg over hypotenuse, I get 3584. Okay? What's the complement of 21? Okay? 69 degrees. We come over to 69. Look at the cosine. The adjacent leg divided by the hypotenuse, the same 2 numbers simplify to 3584. You'll notice that the sine of 69 and the cosine of 21 are the same number. The only difference would be the tangent. Okay, here's that relationship. So the sine of A and the cosine of 89 are the same number. The charts kind of go backwards that way. Okay? The sine and the cosine are always less than 1. The tangent can be greater than 1. Okay? Why this has gone from a dark to a light view, I really don't know, but we'll check it out. Okay? So that's the chart. You're going to see that. Now, most of you have that chart already programmed into your calculator. Now, I can't tell you a one-size-fits-all on how to use your calculator for that, okay? Because some are different. Some you push sine before the degree, some you push the degree before the function. You've got to use your directions, okay? Most of them have a little cheat sheet inside the cover or the case for the calculator. Go over that. Use it. It makes life easier. Trigonometry absolutely requires a calculator. There's no question about it. Okay? The next thing we're going to deal with is setting up these ratios. Not really sure what happened here. There we go. I tell you how important it is to have a calculator, and then I can't find mine. Not good. Okay, so let's take our little stroll over here. We're going to deal with these. Oh, I think we'll use this and this just because. Okay. So what I'm going to do is set these up for you. I've got a triangle with two examples. Okay? And here it is. Okay, so we have example 1 and example 2. Example 1 is already lined up for you. Okay? The directions are going to be the same for both. Find the sine of angle L, the cosine of angle L, the tangent of angle L. Find the sine, the cosine, and the tangent of angle M. Now, it also asks you to express each as a fraction and a decimal. Okay, we're going to deal with that. If you forgot, it's going to be an easy memory. Okay, here we go. So we're going to start with the sine of L. We always abbreviate. Sine of L equals the opposite leg over the hypotenuse. The cosine of L is the adjacent leg over the hypotenuse. The tangent of L is going to equal the opposite leg over the adjacent leg. Okay? The sine of L, the cosine of L, the tangent of L. Okay? This is where you take out your calculator and divide 15 by 39, and you're going to get okay? Divide 36 by 39. Divide 15 by 36. Okay? That's all it's asking us to do right now. You You got to read your directions on this. It's important because you don't have to do any more than that. Set it up as a fraction, turn that into the decimal. Okay, we're going to work through that in a second. Okay, that's it for the L. We'll do the same thing for the M. Okay, so we've got we go from M, this is the opposite leg, still a hypotenuse. The cosine, okay, from M, this is the adjacent leg, it's the one next to it. Okay, and finally the tangent, opposite leg over adjacent leg. And we turn those into decimals. Okay? Now, yes, I want you to notice something. Okay? First off, gravity still works. Okay? Here and here. As I kind of explained a second ago, those are the same, okay? And it's going to work that way because the L and the M are complementary angles. So we always have to take into account, okay? Sometimes you may not get the information that you're looking for and you go, but wait, if I look at it from the other angle, I'll be able to get that. Okay, so we subtract from 90, get the other angle, and it'll be easier to see. Okay? So those are going to be the same, and you'll notice those are also the same. It's the way it works. If we wanted to find the degree measure, now we use the chart or the calculator. Okay? See? So if I look at 0.3846, I'm using sine, so I come down the sine column until I find the number closest to 3846. And it's somewhere in between 22 degrees and 23 degrees. Okay? If it's like that on a quiz or a test, I'll accept either, okay? Because you're there. I also want you to understand about the chart, okay? For the purposes of geometry, whole angles are going to be fine, okay? When you move on, you have to be more exact. I want you to understand this. Each degree, okay, is broken into minutes, 60 of them, just like time, and each minute is broken into seconds. So you can become very precise. You can find them on charts, just Google trig charts, and you can find really, close ones if you need to. Don't worry about it here, okay? That's why we use the approximately equal to sign. Okay? Now, let's go to our next example. Okay? So, example 2, I have these distances. Okay? So, I'm going to use the blue here just to put them in. So, in this one I say ln is 12 radical 3. And the reason I'm leaving the black numbers up is so when I take pictures of it, you'll remember where everything came from. Okay? The nm is 12. The ml is 24. Okay, so here we go again. The sine of L equals opposite leg over hypotenuse. The cosine of L is cute, huh? Is the adjacent leg over the hypotenuse. The tangent of L is the opposite leg over the adjacent leg. Okay? When you see this, and those of you that have picked up on this, yeah, it's a 30, 60, 90, watch what happens. Boom, boom. 1/2. Okay? Boom, boom. Okay? Oh, over 2, excuse me. Okay? Boom, boom. Now, we made a big thing about rationalizing. Don't worry about it here. This is calculator math. Okay? So we're just going to plug the radical 3 and get 1.732. Okay? So you've got 1.732 divided by 2, and you are going to get 0.8. Okay? And then you're going to have 1 divided by 1.732. Okay? Little division, and then break out that calculator. Now, same thing for the m's. Okay? Opposite over hypotenuse. Okay? Adjacent leg over hypotenuse for cosine. Tangent, opposite leg over adjacent leg. We're going to divide again. Same thing. Okay? Boom, boom. The only one here that's different is radical 3. Okay? That's how you're going to set up ratios. Okay? And if you need to, you can find them on the chart. Okay? So, now, we've set up the ratios, we've gone through the chart, let's do examples. Okay? Okay, we've got all kinds of issues going on with stuff here today. Okay, that's better. There we go. Okay, using our concepts here, you may wonder how you use, or which one you use. The easy part is the triangle tells you what you're going to use based upon the information it gives you. Okay? If I look at this, the first thing I see is I've got an angle. I have the opposite leg, and I have the hypotenuse. Now you look real quick because you can look, it's still new to you. Which of the three ratios deals with the opposite leg and the hypotenuse? Yes, it's the sine. So we use that. We say the sine, instead of L or M, we've got 40 degrees here, equals A, opposite leg over hypotenuse. Okay. So, closer. Now you say to yourself, that still doesn't do anything for me. Oh, it does tremendous things. Because now I can go to the chart. Okay, I know I'm dealing with 40 degrees, so I come down to 40 degrees right here. And then I'm using the sine, so I come across to the sine, 0.6428. And now all I'm dealing with, this is a basic math problem, okay? a number equals a over 7. That means I multiply both sides by the denominator. Okay. Calculator, approximately equal to. You're done. The problem will usually tell you to go to the 10th or the 100th place. That's just up to you. Okay? So, we're done with that one. So, the length of A is roughly 4.5. Okay? So that's an example of a sign problem where we're going to find a leg. Okay? Our next one here. Once again, let's look at the problem. Okay? I have an angle. I have the adjacent leg. I have the hypotenuse. Adjacent leg and hypotenuse is cosine. Okay? The more familiar, the easier it's going to be. Okay? So once again, I go to 64 degrees, come down to 64 degrees, come across to cosine, 0.4384. Okay, once again, we have an algebra type of problem. Here's what we have to do. We multiply up. Okay, still hasn't solved the C, but now number times variable. We divide both sides by that number. Okay, calculator for sure. Okay. Okay. Next one, yeah, we're going to use tangent here. So in this case, I don't have the angle, but I have the legs, both of them, as a matter of fact. Okay? Which really screws up the statement, don't have a leg to stand on. Never mind. So I've got the opposite leg and the adjacent leg. That's why it's tangent. Okay, just like we did in the setup. I have both of these numbers. I'm going to turn that into a decimal, which is 0.625. Okay, 0. So what we're going to do now, we go down the tangent column until we get to the number that is closest to 0.625. Okay, and it's really close here. I've got 0.6249 is 32 degrees. X is approximately 32 degrees. Okay? So there's one of each of these. I've got 3 more to go through here. And yes, I know this lecture is a long one, but there's a lot involved in it. Okay? Okay? So, my next one here. I've got a 64-degree angle. I've got the leg and the leg. Once again, we're dealing with a tangent problem because we don't have the hypotenuse. The tangent of the angle equals the opposite leg over the adjacent leg. Find the tangent of 64 degrees on your chart. So you come down to 64 degrees and then come across, okay? Algebra problem, multiply. Okay, so we got about 22 and a half. Okay, I've got two more over here. Yeah, if I'm you, I've already stopped this once to go to the bathroom and get a snack. No question. Okay. So here we go. On this one, okay, I need to find an angle. I have the adjacent leg. I have the hypotenuse. Okay. That's a cosine problem. The cosine of our angle measure so the cosine of some angle is equal to 25 over 30, which becomes 83333. We are going to go down the cosine column till we get closest to that. And for my money, it's right in between 33 and 34 degrees. Once again, you only have to choose one of those. Okay? Our last example. I know, there's cheering going on anywhere people are watching this. Okay? I have an angle. I have to find the adjacent leg. I'm given the hypotenuse. Adjacent leg, hypotenuse. Once again, cosine. Okay, so we are going to go to our chart, go down to 41 degrees, cut across to the cosine, okay, gives us that, multiply, calculator, for the love of God, use your calculator. Okay. Okay. There's that. Okay. Yes, I know this was incredibly long. I apologize, but there's a lot of minutia in this section. So we have to deal with that. And if you still need more examples, I've put another lecture attached to it. Okay? The one I did during summer school this past year. It's got some different examples, a couple of the same examples too. Okay? Just so you can see some extra ones. Definitely go into the notes I provided. There are examples there. Go to Khan Academy. Math is fun. There are a lot of sites that you can find examples on. Okay? And then please, 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 when we're going over the assignment in class, okay, stop waiting for tutoring. Ask questions during the class period. We can go through a lot of things in an hour. Okay? We can go over more examples if we need to. Please get your head wrapped around that. Okay?